In this video, I will be introducing you to Multisim. This is basically like a lab, except we don't have to worry about so many things like noise and spending hours and hours looking for the source of your mistake when you realize you simply didn't turn on the power supply. First, you will need to sign up, filling in some details and confirming your email. In this video, I will be demonstrating Multisim Live, which is the online version. There is also a desktop version of Multisim which has many more advanced settings, but unfortunately that is only available for Windows. I will show you ways around this in a later video, but for now we will stick to the online version. Okay, once you're logged in, you are sent to this page, and in order to get the desktop version or the premium online version, you need to enter a serial number. As UCL students, you can get the premium version for free. To do this, search for the UCL software for students, and from there you will be able to access the list of free databases available for students. From here, you can download LabVIEW for Mac or Windows, which will give you access to your serial number. We can now go back to our Multisim profile settings and enter this number. Click Create New Project, and this white document is where you will be drawing your circuit. You can change the settings of the document by clicking the settings icon. For example, here you can change the size of the document. I'm going to make it 100 grid squares either way. You can zoom in and out with the icon or with your mouse or touchpad. On the left, you have different components to help you draw the simulation. On the top, there are things to do with the actual simulation. So right now we're on schematic, but when we run a simulation, we might want to look at the graphical output of the simulation, or we might want to look at both at the same time. There are different simulation types we can run with, but we'll use interactive for now. This type of simulation acts like an oscilloscope. It looks at what happens to the circuit as time goes on. We can then actively start the simulation and stop it whenever we want. We can rename our project in the information button and choose to make the project public or private, as well as add a small description of what the project is about. Okay, so let's start drawing a simple circuit. Now, something that for some reason Multisim is particularly stringent about is there needs to be a ground somewhere in your circuit. We have many other components we can add, like power supplies, different passive components, active components, but for now we'll just put a resistor in series with a power supply. After we select a resistor and place it somewhere on the document, we're able to rotate it, duplicate it, delete it, and even mirror it, although I don't see much use in mirroring a resistor. We also need a power supply, and of course there are many types, but as an intro we'll just use a DC supply. Finally, we need to make sure that we have a closed loop, so we have to draw wires. To do that, you simply click on the node of an electronic component, then you just move the mouse around, and whenever you want to make a turn, you click on the mouse again. Whenever you reach another node, Multisim will know that is where your wire ends, so it will automatically detach your mouse from the wire. Multisim also automatically labels the ground as node 0 and goes up by 1 at every node. If you want to change any component values, you can either click on the value of the component and use the sweep function, or go to the item settings and then select your component. Here you can change things like ID, the symbol you use, the value of resistance you use. Okay, so now we have a whole circuit. We want to take some measurements, and this is where it might get a little confusing at first, because normally we're used to having two connections to a voltmeter. So first let's just try to measure the voltage on one side of the circuit. We measure 12 volts on this side, and on the other side of the resistor it says 0 volts. So we can conclude that by default, the voltage is measured with respect to ground. However, we usually want to measure the potential difference between two given points, and this is where the reference voltage comes in. We place this reference voltage in the point we want the other probe to measure voltage against. Now, going back to the probe PR1, we can see it has in fact been measuring against ground up to now. And now that we have a reference probe, we can select it to measure against our reference probe instead. We can see that if we now run the simulation, it measures 12 volts across the resistor, which was in fact the EMF of the cell. Anyway, I hope that helped, and I'll see you in the next video.